Welcome students to the last module from the chapter Chemistry in Everyday Life. In this module we are learning about chemistry in cleansing agents, and that too we are going to learn about the types of detergents and also the mechanism of cleansing action. So children, we start with detergents, and now let's come to what exactly are the types of detergents. Now we see that detergents, unlike soaps, the synthetic detergents can be used in hard water. If you remember children, soaps had a big disadvantage that they used to form a gummy mass, which prevented us from using them in hard water. So detergents also do have a disadvantage that they are not completely biodegradable, which means that they will cause water pollution. And the biggest advantage is that we can use them with hard water. So we see that calcium and magnesium salts of detergents are soluble in water, so we can easily use them in hard water. One more advantage are that they do not form curdy white precipitates, which was that gummy mass which soap used to form in hard water. Now children, let's come to the types of detergents. Classification of detergents. We see that there are three types of detergents. The first type of detergent is called as an anionic detergent. The second is a cationic detergent, followed by the third type, which is a non-ionic detergent. So let us start off with anionic detergents. Anionic detergents are sodium detergents. Let's see. An example is sodium lauryl sulfate. Let's see how it is made. We take lauryl alcohol and treat it with concentrated H2SO4. What do we get? We get lauryl hydrogen sulfate. And lauryl hydrogen sulfate, when treated with NaOH, forms sodium lauryl sulfate. Now children, these anionic detergents have anions at the soluble ends of the chains, and they are sodium salts of sulfonated long chains of hydrocarbons or of alcohols. Now, anionic detergents, let's see an example. The example is sodium N-dodecyl benzene sulfonate. This is the structure. Yes children, now we see that in this structure, the anionic part of the detergent is what is going to be taking part in the cleansing action. Now we see that anionic detergents are used while making toothpastes. After anionic detergents, we come to cationic detergents. So these cationic detergents, this is the structure of a cationic detergent. These are quaternary ammonium salts of amines with chlorides, acetates and bromides. Now these have got cations at the soluble ends of the chains. The anions will be chlorides, acetates or bromides, and the cations will be nothing but a long chain of hydrocarbons. We see that cationic detergents are more expensive than those of anionic detergents, hence their use is limited. And we see children, cationic detergents can also be used as germicides. Why can they be used as germicides? Because they have nitrogen. So as long as it is killing the plant or it is killing anything unwanted, what it will do is it is going to give some nitrogen too. Now, cationic detergent, the most common use of it is while preparing conditioners, and hence children, the conditioners are much more expensive than you get the shampoos. Example is cetyl trimethyl ammonium chloride. Yes, this is the molecular structure. It is also known as N-hexadecyl trimethyl ammonium chloride. Now children, after this we come to non-ionic detergents. These are monoesters of polyhydric alcohols or polyethers. This is the structure of pentaerythritol stearate. Also an example is polyether. Now, non-ionic detergents are the ones commonly used in order for preparing detergents to clean vessels. Now children, after detergents, we are going to come to the mechanism of cleansing action of soap. For that, let us consider this molecule. This molecule you see here is a molecule of soap or a detergent. Can you see that this molecule has got a long tail region, and this long tail region is oil soluble. It is an oil soluble hydrocarbon. Since it is oil soluble, I say it is hydrophobic. Now we come to the head region. Yes, this region is said to be the polar head and it is water soluble. Since it is water soluble, I call it as hydrophobic. Now, so we see that a molecule of soap has two parts. First is a long hydrocarbon chain and a water soluble part. Yes, children. Now what we see is when this molecule of soap is added to any oily or greasy part of a cloth or of a vessel, what happens? The hydrocarbon part, which is oil soluble, it goes and it dissolves in the oil. And the water soluble part remains away from the grease or from the oil. Now what happens is the big molecules of oil which might be there on the vessel or in the cloth, they break. Also, the big molecules of soap break too. How? They rub into each other and they break. And what happens is the big molecule of oil is broken into small droplets of oil. And conversion of a big molecule of oil into small droplets is known as emulsification. And these small droplets eventually will be washed away by the stream of water. So children, this is the same way in which soaps act too. So the mechanism of soap and detergent, the cleansing mechanism is the same. Well children, this marks the end of this module and this chapter. Till then, take care.